So if you're growing successfully as a company and you start to see customer demand, pile up, or actually the sheer volume of usage of your system is rising, then scalability oftentimes comes up as an issue. And this is a critical issue that CTOs oftentimes find themselves confronting, and where they have a skill set beyond, say, that of even a senior developer in terms of addressing that. What are we talking about here? Well, from a technical standpoint, if you think of your initial website and what you had set up as being, okay, here's, a simple server, let's say, I'm just gonna, kind of make a straw man version of a system where it's literally just, there's a database, there's my ugly database, there's the app server, and then there's, clients that are calling in to this application, from the outside world. Well, over time, as that load grows, how do you scale a system? Do you do what's called horizontal scaling, where you simply stand up more servers? When I say stand up servers, of course, these days, that's generally happening on the cloud, and whether it's AWS or Azure or whichever system you're using. And so there are techniques you can use to do auto scaling, and to grow out horizontally. You can even auto scale out at the database tier. So this is one approach you might take. This approach actually can add up pretty quickly in terms of costs, but it can be a quick solution, and oftentimes a necessary solution in terms of solving as you've got more load. The other approach, though, that is perhaps less explored these days, but that someone coming with a tech architecture background and with the knowledge of computer science would bring to the table, is actually looking at the performance of the code itself. Because when you're spreading it out across multiple servers, well, you're doing just that. You're spreading the load, but you're not decreasing the load or increasing the speed with which the software actually computes. And so there's something known as order notation. So something like this, which anyone who has studied computer science will be familiar with. And this, I would say, I would say is a baseline expectation for any CTO to bring to the table, being able to look at the code and also to use profiling systems and other performance measurement systems to determine, are there places in this code base that are taking what's called n-squared time, meaning that the time it takes to service a request as they start coming in goes up non-linearly like that, where for a small number of users down here, maybe you're okay, but when you get up to a large load, because of the way the system is operating, all of a sudden your response times explode. And so, that would be n squared. Versus O(n), a log n, constant time. There's, all sorts of things you can measure here, from an algorithmic perspective. But this is some of the capability that I would expect a CTO to bring to the table, to understand when it's appropriate to scale horizontally and just have more boxes. These are very ugly boxes, but have more boxes versus actually examine the code and optimize it. Oftentimes it's the right solution. It's not always the right solution. But that's a key issue. When you start to come up against these constraints, that's when you start to feel the need for a CTO.